Hello, everybody. Welcome to the TeacherCast Educational Broadcasting Network. My name is Jeff Bradbury, and welcome to the TeacherCast Podcast. Tonight, we're talking all about coding and how coding can fit into your curriculum. We have two fantastic guests. First, I want to bring on the author of a great book called Programming in the Primary Grades and the podcaster behind the great podcast called Beyond the Hour of Code, Dr. Sam Patterson. How are you today? Welcome to the program.
I'm doing great today, Jeff. It's a beautiful day here in Southern California, and I'm pleased to be here.
And tonight we're talking all about coding, which is something I know you have a lot of experience with, especially putting coding into the classrooms. And I'm so excited to do that. Before we get into our discussion here, tell us a little bit about where we can hear your awesome podcast.
BeyondTheHourOfCode.com is the website that houses my podcast and supports the book. And it's where I try to put all of my really good ideas about getting kids doing creative things like storytelling with programming.
Excellent. Also on the program tonight, we have from Microsoft YouthSpark, Mr. Todd Beard. Todd, how are you today? Welcome to the program.
Greetings, Jeff, and hello, listeners. It's great to be here from Grand Blanc, Michigan. And I can be found on the Edutainment Teacher on YouTube. I use a lot of my robotics students as demonstration of how to teach coding and kind of seeing the application of how it works. The whole spectrum, kindergarten through 12th grade, and also on edutainmentteacher.com. And you can also find me on the Microsoft Educator Network. I am Todd Beard. And on Twitter at TeacherBeard.
Well, welcome, everybody. We're going to have a great discussion, and we want to know what you guys are thinking out there as far as your computer science habits. Of course, we are here in the beginning of the summertime. Many people are looking at what they're going to be doing next year. We just got back from a fantastic ISTE conference where all over the place, computer science, coding, programming, robotics, that was the hot topic. And we're also going to be talking about something that was called Hack the Classroom that happened on Tuesday night at the Microsoft booth. Stick around. We have a great show for you. Of course, there's several great ways that you can reach out and be a part of this and all of our shows on the TeacherCast Educational Broadcasting Network. You can find us on Twitter at TeacherCast. Leave us a voice message over at teachercast.net/voicemail. Email us at feedback@teachercast.net. And please take a moment today and subscribe to our audio and video shows over at teachercast.net/iTunes and teachercast.net/YouTube. And gentlemen, tonight we're going to be talking all about coding. And I want to start off with a question that Sam and you and I have hit a couple of times. Is there a difference between coding and programming?
It's an interesting question, Todd. Have you ever had to answer this one?
I have not. I've talked about the difference between coding and computer science, but I would love to hear your take on this.
Well, coding and programming, coding involves actually writing code. So if you're dropping in brackets and parentheses and minding your syntax and naming variables and all of that using actual, typing letters, that is coding. The most fundamental coding is like machine language. Programming is when we're doing things that clearly use elements of computer science, and we're manipulating essentially larger units of code. So a great example is the Blockly language. You have programming that you're doing, but you're shifting around these physical blocks, but those physical blocks actually represent the code that would be used to create them. So coding is a level more fundamental than programming. People who cannot code can program.
And when we're looking at the differences between coding and programming, we hear this term computer science an awful lot. Todd, how do you define the term computer science, and why is it important to have a computer science background as our kids are moving from high school into college these days?
Yeah, as an educator, it's so important to expose our kids to computer science because computer science is really the essence of taking problems and breaking them down and being able to assemble them into smaller problems. It's being able to critically think. It's being able to look at something from the outside and be able to deconstruct it and then put it back together. And I think all those aspects are helpful in so many areas of our life that the coding aspect of it, understanding the syntax, that becomes secondary to the real focus that we want our students to have, is those critical thinking skills, right? Those problem solving skills, being able to look at something that doesn't necessarily have a solution right away, and then applying kind of the concepts of computer science to be able to conquer that problem.
And when we're looking at building these computer science programs, I firmly believe it's important to create a curriculum that is inviting to everyone. We recently did a show in partnership with Microsoft talking all about getting more women involved in coding and the Girls Can Code movement here. Could you talk to us a little bit about some of the work that Microsoft is doing in the computer science field to try to help bring coding and computer science to all students?
Yeah, I'm glad you mentioned kind of the female aspects of it. We're really getting into, because of the fact that it is such a male-dominated field. I just returned from Fargo, North Dakota, a while back, and at a DigiGirls camp, we learned how to make a hand that emulated the human hand. So looking at the code of that, we had to figure out, when you bent your real finger, what kind of message that was going to send to the Arduino. And then the Arduino had to interpret that and then send that off to a servo to make that servo turn. And so getting students to understand the biology that was related there and all the different aspects of, computer science, mechanical engineering, electrical engineering, and having them understand that stuff is so crucial. And so there's programs like Girls Who Code, and then YouthSpark is really that all-encompassing. So when you talk about getting everyone excited about computer science, that's where the YouthSparkHub.com comes in. So you have every kind of resource, from getting minorities engaged in computer science, to getting females, to getting young children, to internships and scholarships. There's books that you can read that help with computer science and with STEM and with STEAM, and all that stuff lives at the YouthSparkHub.com, and that's where all those resources are available, so that you can bring those ideas and those resources and materials to people of all ages everywhere.
So, Sam, I know in your position, you are working with the middle school area, and you are working on robots and coding and puppetry, and you're putting all of these things together. What advice do you have for school districts that are out there that are looking to put together some type of a computer science course or curriculum? Where do you start? How do you build it? And at what age can we start bringing these skills into the curriculum?
Well, I think it's really, really important that you don't bring these kind of skills to kids younger than like 3. Because, they got a lot going on up until about 3. But by then, they've pretty much got a handle on most things. So there's actually computer science stuff that's even applicable to ages younger than 3. But the youngest kids I work with are in pre-kindergarten. And there are so many things that are really great about doing computer science and programming activities with young kids. And the one that's nearest and dearest to my doctorate of education earning heart is the fundamental literacy that sequencing develops. So if you have little kids, getting them to program a Bebot robot to move along a path and get to a specific answer helps them get ready to read. Then there's a bunch of these different programming opportunities for our youngest kids. And basically, I look at programming as fundamentally, it's a literacy activity, because it uses the same tools in our brain that we need for reading and writing. And when you finally get to the actual programming part of it, you're working with syntax, you're working with text, and you have to manage all of that. So when you bring it to students, do it as an integrated activity. Do it inside of other classes. Don't even limit it to just science and math class. Expect integration and don't fret over what exactly that's going to look like. Essentially, give the kids the robot and say, okay, Now use that robot to make sense of what was that tale with the Jodes? Grapes of Wrath. And, can be done. It can be done.
Now, Todd, I know you have a younger daughter who's also into computer programming. Tell me a little bit about some of the things that she's doing.
Yeah, so I'm gonna take it back. So back to when Zoe was 3, we did activities from code.org and CS Unplugged. You don't need a computer to do computer science activities. And a perfect example is we made binary bracelets. So her and we learned about kind of the patterns that even at the simplest level that computers speak in binary. And so we looked at the patterns and we saw the letters and how, computers just read on and off, and in doing that activity, it got her, one, to have fun and work with her hands. And I think that's so important at those young ages to get them working with their hands. Zoe's in 10th, Zoe's 10 years old. She's in 4th grade now. And so she grew up with, the NXTs. She grew up with the Ozobots and the Sphero. The greatest interaction I remember is in 4th grade. In DOS, we programmed our computer to play the Michigan fight song, "Hail to the Victors." And I was on the Apple IIe, and we were programming it, and we got it to play the song, and the teacher was so excited, obviously Wolverine alumni. But other than that, I couldn't actually touch the code. I couldn't touch the things that my code was interacting with. I could hear and see them, so that's great for visual learners and auditory learners. But we have this whole door open these days with our kinesthetic learning and being able to hands-on. So if I had to give a second pointer for educators, it's 1, start early, 2, integrate it in every subject, like Sam said, and 3, make sure that you have those hands-on interactions. I'm gonna show you guys a microbit, which is what I've been using lately with kids that are Zoe's age all the way up to high schoolers. So it's really cool, and they're relatively inexpensive.
Now this microbit is something I'm excited to hear you talk about, because I've seen people doing really great stuff with it. It's been available in places that are not the United States for quite some time, and it's now available in the United States, and it is a printed circuit board with an integrated LED display. Is that right?
Yes, not only does it have an integrated LED display, but it's got a built-in accelerometer. So now that opens all kinds of doors for physics. I saw a math teacher teaching slope in the gym with a basketball, connecting a microbit to a basketball with a foam Nerf ball cut in half. He hollowed out the middle. The microbit will work on a 3-volt watch battery, so it's really, really light. And really durable. And so the students took shots, and every student got 3 shots, and they were able to pull that data back and look at it, and they actually found out the formula for a swoosh for that 3-pointer, right? And so they were able to look at the X and Y axis and have it have meaning for once, and have it see this arc that developed, and say, oh, this is what it looks like. This is the formula for a 3-point shot.
Now, that's great, because there you've taken a piece of technology, and that teacher for years might have still walked his whole class there, shot that shot, shown them what, the graph for that would look like, and from the graph showed them what the equation would be, right? And could still get them to do a lot of those things. But that compared to this is like salted fish compared to fresh, right? Like, this is a completely different thing, because the kids are building that experience and getting that data in real time. There's nothing theoretical about what's happening.
That's correct. They own that. They own that, the engagement, and they'll remember that for the rest of their lives.
So, like, that lesson itself, you're saying it used one of these microbits.
Yeah, so you can, they're really inexpensive. I think like for under $15 you can get them, and so a class set becomes very affordable, at 30. And then, he did not have that many. He had maybe 5 or 8 of them, and he had the rigs up, and so obviously there's some variables. The basketball is a little bit different weight and whatever, but the point was that the kids were taking the shot, and then they were writing down in their math journals and keeping it, and then so when they plugged in that data, they could get that acceleration data and pull it into Excel and be able to look at that data, and they had the marks, they had the ones down. Oh, this, shot number 6, shot number 8, and shot number 13 went in. Let's take a look at that data and see, what it has in common. And yeah, it was such a critical thinking explosion of problem solving.
Right, and the whole time they're working with data, right? They're going back and forth from this to equations to figuring this out, and they're working with those numbers, and that's really some of the beautiful stuff that we can do. Now, let's take that same concept and bring it back down a little younger. You mentioned Sphero earlier. I don't know if you've seen the Sphero EDU update, but now when you're using the Sphero EDU app, you can get the accelerometer data from the SPRK Plus Spheros visible. So when it's driving around, you can watch real-time data visualization of what's happening.
I'm glad you just said that, because I just noticed that. I haven't had the chance to test it with students, but that opens up so many doors now. I mean, there's just so many things that I can do to take lessons that were already developed and then add that component right on top.
Right. And I think that's one of the key things, is especially for lessons that are already developed, right? Teachers have been teaching students to work with data forever. And now it's just a matter of finding the right handle to bring that tool in that allows them to see it happening.
Agreed. Let's see. What are some other tools? Another one I wanted to talk about was this new that just came out, is this new Minecraft, the code builder inside of there. And so if you go to makecode.com, you can actually download the software to be able to run your own kind of code in your Minecraft education edition.
That's pretty awesome.
So
there.
I've done some Minecraft related coding that was a Python Raspberry Pi experience, where you open a Python window and you've got Minecraft open, and you can kind of get them to relate that way. What language, what type of coding, what's this experience like? Is it a text-based code?
So good question. So it's based on the Scratch Blackley language from MIT. But then there's some also variations coming, and you can kind of get started with that. And they have the different Blackley templates in there that you can see and kind of go through and be able to do different things with the characters. And then you can actually launch it in a side screen and then be able to see the code that you're creating in the Minecraft world. So you can do everything from blocks to mobs to gameplay, positions, all this stuff. And it's all done through this agent. And it's this agent that you get to command and control. And so it's really cool. There's a bunch of YouTube videos out there of people playing with it. I got a chance to play with it, and you can download a free copy and you can test it out.
Now, I want to take a moment and just walk back a second to touch on one of the points you mentioned, because if somebody isn't that familiar with Minecraft or coding, they might not know the significance of locations in the game. Because the Minecraft world is a three-dimensional world, and it's mapped in the X, Y, and Z coordinate plane. Now, if you have ever tried to teach students three-dimensional design using Tinkercad or another program, you know the challenges of being able to get students to work in and mentally visualize a three-dimensional space on a two-dimensional screen, and getting them to think about what the Z coordinate means and where it is. As a math teacher, I taught algebra for years, and I struggled just getting kids to deal with the X and the Y. And we didn't really talk about 3 dimensions, because why would you do that? But kids today, you want to say, where does math matter? You know, start doing math that relates to three-dimensional space. They're doing it already. They're doing it in Minecraft. They're doing it if they want to 3D print. They're doing it in other game spaces. So like that's a really kind of learning-rich point, and really kind of a standards-rich point of contact with the Minecraft world, as well as 3D printing and design.
Yeah, I can definitely appreciate the springboard that it will give students that have played with that kind of X, Y, and Z access into other avenues. But one of the things is it does require you to have either Windows 10 or El Capitan. So one of the things I want to talk with you about, some more inclusive stuff. So when you talk about what's something that you can use on any device at any time to get any kind of learner engaged, and I wanted to hear some of the things that you use.
Well, Scratch Junior is like one of my go-to works anywhere kind of tools and devices, and it's got enough in it that it can be engaging for just about any age level, especially if you do it in really short bits, right? Like one of the things is, when I came to terms with the fact that each one of these programming experiences is just that, it's an experience. Unless you get down to, oh, I'm actually going to build something from scratch, you're just working with it for a little while. You're creating something and then, moving on. And I like to do storytelling and tours in Scratch Junior. I'll have students do work where they build something and then they'll take 4 pictures of it and use Scratch Junior to animate a tour through the project they built. And it's narrated by the characters that they code. And it takes them less time than it would take them to write the same thing as a Google slide. So the fact that it's coding is almost, dare I say, irrelevant. It's just for them another mode of expression, another way to connect. And Scratch Junior is free, open source, available on so many platforms, and incredibly well supported. The team behind Scratch Junior is a bunch of just like giant-hearted educational geeks who want the world to be smarter and more kind. So you got to love that.
Yeah, and definitely if you got the kids using Scratch Junior, that's the same basis that works in the Minecraft code. It's the same Scratch, and so getting them excited about that can help them lead on to that next level. For me, a great beginner for my kids that will work on any device, and I have it pulled up right here on my cell phone. So this one that I use is Touch Develop. So if you look, it works on Android, it'll work on iOS, it'll work on Mac. It even works on Linux. You got to love that. So
nobody works on Linux. That's exciting.
Right? So I'm launching it right now on my cell phone. And the thing is Touch Develop is that kind of intermediary. So it's not Blockly and it's not a Python or a full-on script. But what it does do is it lets you choose from different tabs on your screen, and you can pick on it, and then you can see what those what that syntax would look like, and then be able to translate it into maybe like a JavaScript or something, or even in Python, and then so here's an example of what that code looks like, and as you can see, it goes right on my cell phone. So instead of typing in the color code, so it is like Blockly in some ways, but as you can see, it kind of takes that intermediate step between Blockly and then going on to the next, and that's just cool because a lot of our teachers are coming from places where we do not have a computer lab, we don't have a laptop cart, we don't have devices for our students, but more and more school districts are getting the braveness to say, hey, BYOD, and kids are going to come with all sorts of devices. They're going to come with their Kindles, they're going to come with their laptops, they're going to come with their netbooks, they're going to come with the best device they can get their hands on. Yeah, and that's the thing, right? Yeah, and it might be a 4-year-old cell phone, but you need to have stuff as a teacher that will work on that 4-year-old cell phone.
That's really exciting because when you were showing me the Touch Develop screen there and kind of what I was saying at the front, it reminded me of App Inventor by MIT, which was really great but limited.
Yeah.
and could be really frustrating. So I'm going to have to definitely check out Touch Develop, because as you were saying, it's an intermediate step because you have the blocks, but on the blocks is the actual syntax.
Yes.
So you're really seeing how that block functions, and it makes sense because when you program, you're always essentially moving around giant blocks of code. Very rarely does any program start with a blank screen and have every character entered by the programmer in order. These are all things that are built out of other things.
Yeah, and then the colors help them too with going to something like Java, where they can see kind of the different things between variables, functions, stuff like that, and be able to associate, okay, these are different things, and then kind of see a pattern in the color. I also brought up, since we were talking about the microbit, you can also do that makecode.com. You can do that on any device. So I don't have to have $15 to buy one of these microbits for each one of my students. I can launch a virtual microbit on my cell phone and be able to code it and then actually see how that code works on my phone without actually having a device. So, you just drag and drop. It's the same Blockly that we're used to. And then you can actually download it onto, you can use your USB port to actually download it onto your microbit if you do have one. And if you don't, you can actually go in and view it on the touchscreen.
Todd, you said that that's running an app, or is that running off of the websites?
It's the website. So that's the thing so one of the problems is with apps is you have to have the right OS environment to run the app. But if you have these web-based things like code.org and like makecode.com and Scratch, these are the things that are really going to make the diversity of schools and students able to use it. It's going to open the floodgates, and that's what we need.
We're finally seeing some return on the promise of HTML5, because you have a number of these. Exactly, it's really exciting because you have a number of these programming platforms that have been built out and are now robust enough to actually work on so many of these different browsers and environments. And having those available is really important. When you're talking about computer science for all, you really, can it be done for almost nothing? Yes. Is a little bit better than almost nothing? Yes. If you want to know how much, I like kind of a minimum. If you can get the groups down to, no more than 4 kids per small group, that can be a pretty good experience. And you can use it to help them develop group work skills, right? Give them some guidance in that and give them a reason to make that collaboration work. Obviously, if you can get that down to 2 students per device, then that's a really nice kind of point, because you can still have that conversation between 2 learners. They can help each other through a point of not being able to figure something out. And when you're coding on a device like that, it is honestly hard to feel like you're an invested piece of the process if you're viewing it upside down, right?
Right. So when you talk about that 2 students per device, and if you're familiar with the code.org curriculum, that's the pilot and navigator scenario, and it works really great. Even if you do have enough devices for everyone to have their own, there's a lot of learning that can happen when you have these pilot navigator teams where students are working together to solve a problem and, taking turns being pilot and being navigator.
Right. And you really have to ask yourself as a teacher, what are my goals for these students? Is my goal that every student gets to the end of this level? Or is my goal that every student understands how this works and masters the concepts behind it? Because if you want them to master the concept behind it, then instead of having them actively do it once, because some of these kids can get this done once. They're like, oh, it's a little game. They play, they win. Yay. And then they move on. Even if both kids are immediately successful, they've each done it twice then, right? They've watched the other student do it. They've walked through it. They rehearse in their head when they sing it. But generally, they're not successful the first time, so they have to work through it, and they have somebody to work that out with. I love under-deploying devices. I often work in a situation where there is definitely, one-to-one tech access, and we under-deploy just for that reason. I don't want to spend my time helping answering individual students' questions, making them think that I somehow know more about this experience than they do when they're sitting in front of the portal that's designed to teach them, right? I'm going to pair them up with an empowered partner, and I'm going to get out of their way because there's 3 of them in that partnership. And one of them is the entire team at code.org who have designed this website to be usable by people.
Sam, let's explore that one a little bit, because we talk a lot about this on the Tech Educators show as tech coaches. Let's kind of explore the topic of how do we get non-computer teachers to jump into the pool here and try this and pick up those skills. As you said, you have an entire team at MIT who designed this platform for the teacher to not, to be able to not know how to do these things. How do you get that science teacher, that math teacher that might be thinking, oh, I don't have to do code, to invest in it literally beyond the hour of code that we're asking them to do?
Well, I think that's all part of the mission of Hour of Code, was really to try to make that happen, to try to give teachers that experience, because it really is something that you have to spend a little bit of time with to understand what it is like in reality and in practice with kids. Because if you're sitting at home and you've never programmed with students about educational content, then I don't know what you're picturing, but it's probably not what happens in my classroom, because I never pictured what happens in my classroom until it happened there. Programming with kids is one of those things where it's a tool you bring in and you don't know exactly what it's going to empower your kids to do. But if you have a couple good examples, if you have a couple kind of lead suggestions, and you can, empower the kids to learn from the platform, you can be in a good situation. When I started, I made the mistake of trying to learn ahead of the kids. That doesn't work. They have all of the time in the world to learn, and they learn like 10 times faster than I do, because my brain is very old and I work hard to keep it elastic, right? We're learning stuff all the time, but I cannot compete with an 8-year-old. It is just not going to happen. So you give them the opportunity to learn, and you, as the teacher, remind yourself what your expertise is, and you focus on that. So that brings us back to, like, what do you want your students to learn? Do you want them to learn to work together and be nice to each other and cooperate and, meet a goal? Great. Give them a robot or an iPad with, a coding program to share, and have them work together on that.
Todd, one of the things that teachers can do when they're looking to bring computer science into their classrooms is to reach out to other teachers who have successfully brought computer science into their classrooms. Could you talk a little bit about the education.microsoft.com portal? What can teachers find there? How can teachers use Microsoft Education to reach out and connect with other teachers to find the right tools and the right resources for their students?
Yeah, so that's kind of actually how my journey started. So I felt like an island, and definitely made some connections on Twitter and on Facebook and at conferences. But still, I was looking for teachers that could help me in very specific areas. And so that's where I went to education.microsoft.com. I created a profile and looked for other teachers that I could Skype with, and look for other resources that I could bring into my classroom for any teacher that feels, daunted by computer science or by Skyping or any of those things. I think the first step is logging into that community and seeing that there are people out there that can help. Jeff and I are MIE experts, and we can tell you that when we first started as MIEs, we were just looking for resources. We were looking for connections with people. We were looking for curriculum. We were looking for anything we could get our hands on. And so that really brought it all together. And I think the most valuable part about that experience has been the people, the connections, like Sam and Jeff and all these other MIEs across the United States that, if I have a question on my computer, I can go to my GroupMe and I can ask that question. It gets answered in seriously like 10 seconds. I even have my IT staff at school that will text me questions because they know that I can retrieve stuff quicker than them looking it up through the blogs. And so the relationships, just simply, joining a community, another PLC, or PLN, however you want to talk about it, but your professional learning community or network. And it's a great place. If you're already part of a few of them, one more is going to just increase your reach that much more.
And I got to ask you the question that I like asking all of my MIE guests. What does the MIE program mean to you?
So to me, it means sharing. And really, it is a bunch of us sharing our experiences. And, it's not always about technology. That's what I love about the group is sometimes we're dealing with an administrative situation or a student situation. It could be anything from behavior to time of day to school year, and everyone can talk about their experiences and they're outside of your box, right? So we're so used to hearing people in our state or in our county or in our school or in our district, and it's a great relief to hear people from outside and to be able to hear about solutions and then bring those to your school and say, hey, this worked here, maybe it could work for us.
Now, Sam, I know as a member of the coding community, you must have a lot of resources that are out there. I know your website, mypaperlessclassroom.com, not only is it fantastic, it's also one of the top 50 EdTech blogs of last year. Where do you go to find your resources and gain your information? And who do you reach out to maybe on the social webs when you're looking for some information?
Right. There's a lot of great people out there doing amazing stuff. And if I'm looking for content specific information, there's all kinds of, specific teachers I reach out to. I like, as Todd said, community is important. There's a great community over in the Sphero world connected to the SPRK or the Sphero Education, app. That's a pretty good community with a lot of really good kind of raw ideas. So if I'm looking for something like that, I go there. If I'm looking for something a little more nuanced, or I really want someone's thoughtful input on something, then I spend a lot of time in a few different Facebook groups. I like the Makey Educators group. And but if I'm just looking for like solid, good education, TeacherCast is my number one resource.
Oh, thanks.
Yes.
Sam. And Todd, before we go, could you talk to us a little bit about the YouthSpark program? How does anybody find it? How do you check it out? How do we get in touch with it? Tell us a little bit about YouthSpark.
Yeah. So first off, go to youthsparkhub.com. And when you get there, you will see that there is a whole range of offerings that every teacher can appreciate, whether you're teaching kindergarten or 12th grade, whether you're teaching language arts or math. It really connects teachers with resources. And so things like if you've seen PBS's Road Trip Nation, there's a program called Code Trip Nation where we talk about computer science, and that's part of YouthSpark. Maybe you're looking to bring computer science to your high school, but you don't have anyone that can teach it. If you check out tealsk12.org, that's another YouthSpark program that talks about bringing in IT professionals that are working in the field to come in for the first hour of high school and teach at your school. And that, they are the expert on IT, but they work with teachers that are experts in learning. And so there's different models and modes, but they work with these teachers for 3 years until they feel like they can do it on their own. And so this is just two examples of the multitude 30 plus programs that are available on the YouthSpark Hub. And they all have to do with getting people excited about computer science.
And of course, there's several great things that we can find in the podcasting land, in the ebook land, and of course, let's just do one more thing here. Favorites computer science hashtags? Is there anything that's good that's out there, Sam? What do you use?
The CSK8 chat is, or is it CSK12? Maybe it's CSK12 chat.
Okay. Well,
no, I think it's CSK8. It's so good, I don't remember it. It's in my tweet deck. It's one of those things.
We'll make sure we have it on the show
Vicky
notes.
Sedgwick, who on Twitter is @VisionsByVicky, is amazing and a great participant in that chat, and always has really great ideas for doing great stuff with robots on a budget.
Very nice. Todd, where do you go on the Twitters?
I'm a huge advocate. So there's tons of stuff you can go for resources and stuff, but the reality is we need more people. Hashtag CS for all. It was an initiative a year ago, but we need to make sure that this program gets funded, and we need to make sure that it has adequate resources. It's rolling out state by state, and so the reality is we need everyone out there to reach out to your local state legislators, because I think reality is there's only like 7 states right now that have a CS kind of mandate, or not mandates are bad, but a CS, focus on making sure that their students are ready. And actually this year it's 5 more adding on, so it'll be 12. But you need to look at the stuff out there besides. So hashtag CS for all. Code.org is another great resource to see is my state doing anything about getting computer science, and if so, how are they addressing it? Are they making it as a possible math credit? Are they making it as a possible science credit? Are they making it as a possible foreign language credit? Because these are all important things that need to be talked about, and we need support from K through 8 especially, but K through 12, we need our voices to be heard. So that's the hashtag that I go to, because we need to get the word out.
So let's recap a little bit. What have we learned so far? We've learned that computer science is alive and well. There's a lot of great things that are out there, lots of great resources. We're going to have a list of those over in our show notes. We know that it's absolutely imperative to not only get your students involved, but really get every student involved. Get your the whole Girls Can Code movement is very, very important for all school districts that are out there. We know that the BYOD movement and computer science can work together. As Sam said, thanks to the HTML5 platform, you can be running any type of device, just about, and be able to lock into some of these great websites and be able to do Scratch-based coding or any other kinds of coding that's out there for websites. There's a lot of great resources, and there's certainly a lot of great communities. We're going to be putting together a whole list for this, and the one thing I would definitely encourage anybody to do is, check out education.microsoft.com, check out youthsparkhub.com. There's a lot of great things that are out there. Check out mypaperlessclassroom.com, and of course, you can reach out to everybody here on their social networks. Guys, thank you so much for being here. Todd, where can we learn more about the things that are happening with you on your social networks, and how can we find you?
Yeah, definitely follow me at TeacherBeard. Also, you can catch me on TeacherCast, and definitely on Simple K-12, and you can see me on the educator community at educator.microsoft.com, and on the Edutainment Teacher on YouTube, and the just edutainmentteacher.com is my website, where I talk about all the things that are going on with me.
Nice. And Sam, where can we find out more about the great things that you're doing?
You can find me and all of my things and links to the rest at mypaperlessclassroom.com.
And one more time, thank you guys out there for taking time to join TeacherCast today and being part of this podcast. There's, of course, several great things that you can do to be a part of this and all of our shows. You can find us on Twitter at TeacherCast. Leave us a voice message over at teachercast.net/voicemail. Email us at feedback@teachercast.net. And please join everybody out there who has already signed up and subscribed to this audio and this video show over at teachercast.net/iTunes and teachercast.net/YouTube. On behalf of everybody here on the TeacherCast Educational Broadcasting Network, my name is Jeff Bradbury, reminding you to keep up the great work in your classrooms and continue sharing your passions with your students.